All right, so we're going to start solving application problems using right triangle trigonometry. So a lot of these are surveying problems like 13. There's several guy wire problems like 14, and then angle of elevation and depression problems are pretty common also. So on 13, I'm standing at a point A on one side of a river and wish to measure the distance across the river to a house H on the other side. I walk 50 feet down the riverbank to point B and the measure of angle ABH to be 18 degrees 23 minutes. The minute is missing. All right, find the distance across the river. We're going to assume it's a right triangle. So the first thing you guys want to do on all of these is draw a diagram. It should eventually be a right triangle, but I'm going to draw a river. It's my water. Okay, so I am at point A. There's a house across the river at H. And then I walk down the river to point B. And I have a tool I can use to measure an angle across the river. So surveyors really have to do things like that when they can't measure across a river or they can't measure across a street that's really busy. So they have to use trigonometry to figure out how to do that. All right, so you guys take that triangle and label what you know, and then we'll figure out what we're trying to find. All right, so we want to find across the river, so I'm going to call that lowercase b since it's opposite of angle B. Okay, so then we need to figure out what trig ratio to use with our given information and what we want to find. So we have this angle and this side, and we want that side. And so that's going to be the tangent of 18 degrees 23 minutes is equal to the opposite over the adjacent. All right, and then when the variable is up high, you're going to multiply. All right, on the challenge exam, you would stop right there. You would go ahead and just choose that answer. Same thing on the ACT. The ACT is written so you can do it without a graphing calculator. But I'm going to have you guys go ahead and type that in. So don't forget, your calculator needs to be in degree mode. And then to get degree, minutes, seconds, you're going to do seconds, apps. Okay, we're going to round to 2 decimal places on these, and we are going to label the unit. So because the distance we walked was in feet, then this is also going to need to be feet. Okay, so let's look at the next one. A guy wire must be attached to a 50-foot pole. The angle the guy wire makes with the ground is 75.5 degrees. We're going to find the length of the wire required to do the job. Now, these wires can be attached at the top of the pole or in the middle, somewhere in the middle. If it doesn't specify one way or the other, we're going to assume that it's at the top. So those wires are for support if the telephone pole is too tall. All right, I didn't draw a really great horizontal line, but the ground should be horizontal. Okay, so label what you know. The pole is the vertical distance, and then the hypotenuse is going to be the wire. I'm just going to call it W. All right, and looking at what we have and what we want, we're going to use sine. And then when the variable is down low, we're going to switch, So W and the sine of 75.5 degrees will switch. And like I said before, this is all you would need to do for the challenge exam or the ACT. But we'll go ahead and type it in. And you should get 51.65 feet is the distance of the wire required. Okay, so let's talk about angles of elevation and depression real quick. So angles of elevation and depression. So a person at point A looks up at point B. An angle of elevation with the ground is created. When B looks down at point A, the angle of depression is created with the horizontal. These two angles are congruent. So this is something a lot of people remember from geometry. So we have two horizontal lines that will be parallel to each other. And then a transversal is in between them. So what the angle of elevation and depression create are alternate interior angles, and alternate interior angles are congruent. Okay. So I use that because sometimes my angle of depression might not be in my triangle, and then I'll just go ahead and switch it to the angle of elevation because they're congruent angles. There's no reason to draw another triangle. And one thing I want you guys to absolutely remember, underline it if you need to, is that angles of elevation and depression are always created with the horizontal. Never with a vertical line, always with a horizontal. All right, so let's do a few of these. For 15, a device for measuring cloud height at night consists of a vertical beam of light that makes a spot on the clouds.